Hey, hello. I hope you can hear me well. Um, if not, please let me know in the comments. First, I'm going to show you the checking link, so you can go there and please check in for this event. Here's the link. Yeah, and what we're going to do today, right? Which is building a video game in JavaScript on the web browser. Let me start reading some comments. Please drop the link for the app check-in. Thank you. Here's the link. So go there and don't forget to check in. Hi, you were waiting for this. Awesome. MLH is now. Oh, this is another one of you. Hello to everyone. Okay, so hey, I missed a lot of events because my university where I can find the previous evening videos. You're commenting from YouTube, so you can find it in YouTube. I don't know if they are uploaded just after the transmission ended, but I'm for sure that that happened on Twitch. So if you go to Twitch, all the videos, the streams, and everything are recorded on the MLH page. So please go to stream, even on our Facebook, YouTube, all the places where we stream. You can find the videos. Next question. Thanks. So, getting back on topic, video games, right? Uh, yeah, don't worry. Video games. If you remember, some weeks ago we were talking about APIs, right? I host a technical event just like this, talking about all the APIs available in the web browsers, and we talk about one in a specific that it's very important for today's session, which is WebGL. WebGL is a web API based on OpenGL. which is like this graphic standard that allows us to create amazing animations in the web browsers for two-dimensional and three-dimensional um, graphics, right? Sir, those challenges change every day. P.S. I'm new. Um, about the challenges, I'm not sure. You can see the stream before. They were talking about the entire day. I'm sorry I can't answer that, but yeah, I recommend you to check on the previous stream, which was today in Global Hack Week,
Which
stream an hour
was
ago. Oh, sorry. Um, Audio got mixed up. I'm sorry I can't answer that, but yeah, that's my recommendation. Go there and see the stream before me. Um, how we complete everyday challenges, same. All those questions, you can go and you can attend actually the today in Global Hack Week and ask these questions on the live Q&A. They have more information on that. But yeah, returning to the this session, um, we're talking about OpenGL, WebGL, which is the web API. We need to. Sorry, this bleep for a second. Can you hear me well? I just want to make sure. Please let me know in the comments. Yeah, the API who makes this possible it's WebGL. But there are like top layers of that we need to use in order to get or to be successful with our video games creation, right? So if you come from a background like you already build um, video games using Unity or what's the other one? It's very famous. Ah, in Real Engine, yeah. You're probably familiar with these engines or the engine, yeah, the engine concept. If you don't worry. Just think it up as if these are technical tools we use to delegate responsibilities to other programs so we don't need to take care of certain things or graphics or running cycles, etc. Um, well, it's the same for JavaScript. In JavaScript, we have these engines, for example, Phaser, Pixie.js, Babylon. Uh, per se, it's not an engine, but a very useful tool for creating, yeah, to create 3D and 2D animations, 3JS. I'm going to share with you all the links, and we are going to check the other pages. And then we're going to follow these steps on the Mozilla Web Apps documentation to create our first beta game, right? Uh, I want to make this as interactive as I can, so at any moment, share your comments here on the comment section, and I will read them and I will try to answer your questions. So let's start with sharing those pages I mentioned before. Um, Wait a second. Wait a second. Just wait a second. Yeah, when I stream, my computer does not work so properly. I probably need a more powerful computer. Share screen. Okay. Okay. WebGL 2 and three-dimensional graphics for the web, right? Let's take a deeper look on this page. Let me share first with you the link so you don't need to see my screen, you can scroll it by yourself. Here it is. You can copy and paste it. Yep, here it is. Uh, WebGL. If you see this, like the path here, it's a web API. Again, we talked about this before, but we do not talk in depth as we are going to talk now. Um, Again, if you want to go back and see the recordings for the Happy Week from the sorry, Global Hack Week, you can do it. It was a good session, very informative. But now, WebGL, it's a web API, web graphics library based on OpenGL. OpenGL, it's the standard for graphics. NVIDIA and a lot of other enterprises work for that. So here we have the compatibility table, which is very important depending on what browser you are using. You will have um, some things you can use and some things you can not use. But let's get to that. Again, this WebGL2 produce much supporter than the previous before because it's OpenGL base 3 and the other one it's OpenGL base 2. We have all the references for the things we can do, the extensions, the events, constants and types, and we're talking about WebGL 1 in this session, but you can see further in WebGL 2. It's a major update, but not all browsers support it, so it doesn't matter. And here's the thing we are going to follow the WebGL tutorial. We also have a lot of more documentation, best practices, all the data, extensions, um, advanced tutorials, resources. For example, here in the resources, we can find the Chronos WebGL site. Chronos is the main group behind OpenGL and WebGL by default. So let's see the Chronos group, WebGL. Here we have more documentations from the creators, the standards, the specification, even the GitHub repository if you want to check it out. And I don't know, maybe contribute. It one by yourself. They even have a cool stuff section. And if you want to be more close to the community, you could do it by the Google groups they have, the newsletter, the Stack Overflow, and the Slack. Okay, but that's it for this page. Let's get back. Here, we will talking about these libraries, right? I mentioned 3GS as a library that use WebGL. This allows you, and this is something we uh, also talked before in the previous API session. But here we can find a lot of incredible examples. I remember we opened this one, and we this is like a page when you can scroll and see the entire body of the car. Let's open a new one to see. I don't know. For example, this one of sneakers because I'm a sneaker lover. So IR fake sneakers, and you can see these ones look nice. So I'm going to open it. We can view it in 3D. This is the amazing thing about this. Look how I can get zoom, pan, see around, change the view, and I will even change the color of this. Look at that amazing animations. Look at how the lights change it. And this is web. I mean, I'm very amazed because I remember um, different times in which these were like a dream. You used to need a lot of computational effort and a lot of yeah, a very good connection, a very good computer just to even think of this. And as I was saying, my computer is very slow right now, and I am still able to run this web page and stream it to you at the moment, right? You don't see it pause, or you don't see it like cut. You see it smoothly, and that's a very good thing. But this is not video games per se. You can do video games because you can interact with these 3D animations, and well, you could do video games, but this is not focused for video games. Let's take a look of some things that are focused on video games. For example, Babylon. Babylon is render engine focused for video games. They give you information about fluids, performance. They have like these textures. Uh, I haven't tried it on my own, but I have heard a lot of good things from this. Oh, and there are here some examples of what can we do. And again, they have like this media if you want to follow them. Let's open the next one, which is Pixie.js. Pixie.js, again, I haven't tried by my own, but they are winning a lot. You're able to hear that these people are making like a lot of noise. Um, for example, here, the partners they are working. I think it's amazing. uh, you can create fully oh, but this is just for two dimensional. Oh, yeah, okay, this is for two dimensional. They don't trouble getting with the third dimension. Okay, but again, here's the reference. You can take it, you can go there and try it. um, the next one is one that I have uh, tried before, which is Phaser and Play Canvas. Let's take a look at that. Phaser. In my experience, I really enjoyed. Oh, we're coming to a reel of the website. This is funny. Well, I was going to talk good things about the Phaser, but I don't really. I don't think this is a good thing. Just build taking down your website. Well, okay, but come here, give it a try on Facer later when the website is up, and you will see they have good things. And when I worked with Facer, I remember it was a good time. And yeah, sorry for having their website down. Play Canvas, it's the last we are going to see because, as you see, there are a lot of more. Not even listed here. There are lots of more. Play Canvas, it's the one I use in my work when we wanted to build a video game inside of application. So to talk about that, you can imagine having an app. It's heavy, right? Because we used a lot of tracking information, a lot of geolocalization data, etc. So imagine having that plus a video game. It was like a big challenge, and or try trying to implement Unity. inside, like running Unity inside the app, like an iframe, but that was just not working well with uh, low gamma devices. And even in the iPhones and the big gamma ones, that was really slow. So we tried with Play Canvas, and the results were amazing. To be honest, we don't have trouble with performance or battery consumption, even with how to say it. The amount of network required to handle all the information. Yeah, Play Canvas, it's really nice, and we can try to get an, an a video game running from this. Um, Trusted by. Okay, with this, sorry, I don't know why, but I remember something I wanted to say to you. But let me go back and read some comments first. Sweet. Okay, that's the only comment. I just hoping you're enjoying this. Um, I remember at the beginning to answer one question you probably be asking yourselves: why JavaScript and why video games on the web? I mean, there are, as we talked before, a lot of tools like Unity, like Unreal, and you can build even in Procreate, I think it was. I don't know. But you can do Java, you can do C, you can do C Sharp, you can do a lot of languages to build your video games. But mm, I think JavaScript has an has a very good edge over all the other languages, like being the default language on the web, right? If you want to go web, you need JavaScript. And why try to make the web run any other language that is not JavaScript? Uh, it's possible. And if you go now and just Google video games JavaScript, you will realize that a lot of web video games that you may played in your childhood that you may play even now or even in your mobile devices are built in JavaScript. And that's the other thing. Mobile and web are really close things. And once you build something from web, it's really easy to move it to mobile, to iOS, to Android, or any other mobile device you have. um, so that's a good advantage. That's a great advantage. I mean, you just have to build to one and just export it uh, to all the devices you want. And let's say if you come from a web developer background, just like me, and you want to start your journey in video game developing, you want to become now a video game um, creator, I'm not saying you don't need to learn the other ones. I just say that the easy way to start on that once your background is this, it's start with JavaScript. It's a tool you have. Just use it. And if you're not a web developer, but you want to do video games, well, it's up to you. I'd say the advantages JavaScript has, but I need to say the disadvantages it has, right? So I would say for most um, robust video games, let's say it that way, if you want to build a video game for a game console, for a native desktop, if you want to go depth in the things you want to control in the yeah, in the performance, etc. You probably are you're not using the right tool with JavaScript. You probably will need Java or C sharp, etc. So again, up to you, up to what you want and how you want to build it. But here, let's make something really easy and really quick, right? So that's the other advantage of JavaScript. What's the good resource to get started with some basic gaming code? Oof. Mm, there is no one great resource. For example, here in the page, I just shared the developer Mozilla. Um, if you follow the tutorials, you will find a tutorial for video games. And in the pages I mentioned before, I can remember if it was Pixie, Babylon, or maybe in all of them, you have like tutorials on how to build your first video games. And you can even see examples of the video games that are already built. So I think that's a cool thing because you can see how things are done. Um, so yeah, video games and open source again are running the internet, right? If I found something, okay, I think I have a resource. Let me share it with you. Talking more about examples. Here in this page, digitaljournal.com/JavaScript games, you can find more than 30 JavaScript video game examples, and some of them has tutorials and step by step of how to build them. Some of them don't, but you can see the source code. Again, that's where we're talking about. You can see how things are done. You can try to modify them. You can try to add a feature. I don't know. You can do whatever you want with them, and that's a great way to learn. Well, I think. But yeah, again, no, it's that you don't have a one great source, right? There are a lot of great sources. Just start developing. And something I want to get clear from this is I'm not too a video game developer. This is not my work. This is not what I do for a living. This is not a common hobby, a common passion I have. I do love video games, but I'm not that into building video games. So right now, I'm just trying to share how I could do it, having my resources, which is knowing JavaScript and knowing web developer. And if you are like in a similar position as me, you can do it the same. Yeah, I love JavaScript too. It's like my favorite language. Yeah, me too. I'm also a web dev and I want to try exactly just like you, brother. Um, how can I switch from web only to game dev using JS? Because I was thinking to transition into game development, but I can't find any guidance about it. So can you tell me some good things for this? Okay. Um, Talking about the guidance that you don't find, I think because the video game market, it's I don't want to say in diapers, but there's not like a common thing to say I want to be a video game developer, right? Um, I remember when I was talking with of this topic with cousin, he wants to be a video game developer, and he is younger than me. I don't know, like, yeah, almost like 10 years. God, I'm old, but yeah, he wants to be a game developer, and we were talking about schools and things like that. You cannot find good school programs focused on that. You need basically to, yeah, to learn software developer, computer science, etc., and then focus your abilities to video games, or take extra time, study by yourself, etc. At least that's the case here in Mexico. I don't know if any other country has a school dedicated for that. In Mexico, we have one, but it's a paid university and it's very, very expensive. So it's not an option for us. Um, how could you transition from web to video game? I will say start making video games like by yourself, just indie video games. You can try to replicate existing video games, but for example, if you see something that you like that it's just for I don't know, Xbox, or yeah, a closed platform, you could try do it in JavaScript and get it to web. Once it's online, it's easy access for everyone, and start, I don't know, make it for iOS and Android. Build an app. Once you have that app, you can try getting paid for that app. That will be my advice. Uh, Thank you. I will check that out. I tried the Python, but I found it difficult. Oh, I haven't tried it. What you find difficult? Can you share more with us? Maybe I can give you an advice on that. My school has a good game dev program. Cool. What's your school? Are you currently studying what major? I don't think we have that in India. Yeah, no. Yeah, it's kind of difficult to find, but it is expensive because it's on a campus, not online. Yeah, yeah, it is expensive to try to study or try to learn video game developer. All things related to animation and 3D and that things. I don't know why, but they are too expensive. Chilling with WebGL, learning from empty docs. Exactly. Yeah. I am a beginner in web dev. Okay. So my advice would be don't try. How to say it? Don't get too overwhelmed. But yeah, don't get too overwhelmed. That will be it. Because to be honest, web it's very, very huge. Like it's a big world, and if you want to if you try to tackle all of them, you probably get overwhelmed. Start get a good path, get a good idea of what you want, and yeah, start taking one step after another. I am beginner, just start with Python. What should I do next? Okay, almost same advice. Have an idea of what you want, because development it's a big world, not just talking about just web. But get the idea of what you want to do, and once you know what you want to do, um, you will have a clearer path of what can you actually do. Yeah, MDM are like a perfect tool for web dev. People also Reddit. Yeah, exactly. I always recommend MDM, the Mozilla documentation. So, taking advantage of this comment, let's hope back on the Mozilla web documentation and start building this. Okay, let me find the tutorial. model view projection, WebGL tutorial. This tutorial describes how to use the canvas element of the WebGL graphics, etc. We need to know how to use JavaScript, HTML, and CSS, of course, right? Before you start, need to okay. Again, this thing bleep. Um, if anything, just let me know in the comment. Using the canvas element is not very difficult, but you need to have a basic understanding of HTML and JavaScript. In this tutorial, we're going to know how to get started with the context of WebGL, add a two-dimensional content, using shaders to apply color, animate the object, and then create our 3D, in this case, a cube component. Then we are going to use the textures, and we are going to add some lights. Um, yeah, that's the all the tutorial, right? But this is not for uh, video games per se. This is just the starting for that. We are going to have the second part on Friday, in which we are going to apply this knowledge to build the more advanced project, right? We will check time, but well, after we finish this, we will start with the next tutorial to see if we can apply this to control with the computer keys, and that's a video game. And on Friday, we are going to use Play Canvas to do it in a more uh, pro way, right? With real video game textures, with real like controls and etc., and in a real engine. Right now, just let's close this and hit with getting started with WebGL. WebGL enables web content to API, etc., etc. If we want to keep exploring the code, there's a GitHub repo for that. It's worth nothing here that is a serious article introduced the WebGL itself. However, there are a number of frameworks available that encapsulates WebGL. This is what we were talking about. Uh, right now we are going to learn the basics, very basic things, right? But this will help us to understand what the next things like 3GS, Babylon, in our case, Play Canvas, encapsulates, which is the API. Preparing to render in 3D. First, we need to create two files. Let me share my I will stop sharing that and let me start sharing my. Um, sorry, I forgot the name. Visual Studio Code, the Visual Studio Code, the screen. 1 second, it's opening. Any questions this far? Well, I already answered some of them, but okay. It took a little moment here to open, but I think you should see it now. Oh no. Okay. I don't know why. Okay, let's try with full screen. Okay, you should see my full screen now. Yeah, and here's the Visual Studio Code. And let's move. So that was saying we need two files, index.html and webgl demos.js. Let's copy and paste this name, and let's open a terminal here and create this file, webgl demo.js, and the index.html file. We have both now. Let's see what else we need to do. The index.js should contain the following, which is a basic HTML structure. Just with the title WebGL, it um, gets the script from the WebGL demo.js file, and it's a model type. And here, as you can see, we have the canvas with the ID. Uh, this is just a canvas tag. So let me open this on, let's go live, and let's open the inspector and inspect this. As you can see, it's just a regular canvas with a width and height declared already in the document. We can modify this, we can change this, whatever you want. If you don't want to strictly follow the tutorial, it's okay. If you're new in this, again, you just need to copy and paste to see. I will explain the code. If you are like more familiar with what are we doing, feel free to modify whatever value you want. For example, uh, this is basic things, but again, this is for all people. So if we modified here the title web, it's instead of in space. A line here separating the names. We should see the changes here on the tab. You see it changes. If we change the width here, for example, let's see 700 uh, width, 700 height to make it a square, and we inspect the size now, you should see it, and it covers all over the page almost, and it's 700 by times 700. Okay, so let's continue. Once that's clarified, now that this declares a canvas exactly, it declares the canvas. We are going to draw into prepare the WebGL content. So in the WebGL demos file, we copy and paste this, and let's explore the file, right? So we open a main function. We call it at the beginning. This, if you want to, the common way I do this, to be honest, it's I encapsulate this here and then execute it. But that's my preferences, right? You can do it the way it's here, and that only means you're executing the function you declare before. Uh, Remember, functions have this called hoisting, so it doesn't matter. It's not already declared here because the hoisting tells JavaScript running engine that this function exists. If you were on Java, on other languages, this probably won't work, right? So uh, In first, we declare a canvas, and we get the GL canvas, uh, which is the canvas element on our HTML. So we have this canvas from our HTML using a query selector, and then we get the context of WebGL from the canvas. Once we have that context, if we check that the context exists, that means our browser supports WebGL. If not, our browser probably don't support the WebGL machine, right? We return the function and we set on the context using these methods the color, and we clear the buffer with the specified color. Let's see if this is working. Yes, as you see, the color change. This color, well, it's black, right? If we want to get more context of what get our clear color is, we can go here and open a new MDN web doc. Oh, I want to be it the same. And in here, well, we are going to use get color. Well, we can just type it, right? Clear color. Well, GL clear color. And this is from the rendering context clear color method, the clear color method of the WebGL API. Remember, this is what we are getting from this line before. Um, Specifies the color values we use when clearing the color buffers. So here's the syntax. We have red, green, blue, and alpha, as we are giving 0 to every color here. Remember, RGB for 000, it's black, and the alpha, it's like the opacity we want to get from here. If we change this to all red, you can see difference here, but I don't want it to be as defined. I want to be half defined. Yeah. Okay. So that's the way you can understand more of what we are doing if you keep having questions. But let's continue. The main function it's called when our script is loaded. It's supposed to set up the context from WebGL. And the first thing we need to do is obtain the reference of the canvas. Yeah, we talk about that. Once we have the canvas reference, we try to get a rendering context, calling get the context, and pasting the WebGL. If the browsers do not support it, it will return no. We talk about it. If the context is successfully initialized, we have the GL, which is our reference, or GL value, right? So our next step, what should be it? Adding two-dimensional content to this context we already have. How can we do that? Well, we need to update our uh, HTML. Let's update it. We change some things here. For example, we add a CS style sheet. We should probably add it next. We add in the script at the CDN. We add a script from someplace in internet. Cloud for CDN, access, library, GL, metrics. Okay. and we are allowing the cross origin, and we still have our script from our WebGL demo.js. So yeah, that's the thing. We add this script from the internet, and we add a CSS document. Let's see, drawing the scene, the shaders, I recommend you to read these, not just scrolling down, but well, thanks to this is what we're going to do. Now we need to add this to our main function. I suppose it doesn't matter where, so I am adding it at the end. Okay, here it is. And we also need to add this another thing. Um, we need to add these functions, not to the demo. They go no to the main, to the file, which are the ones in its shader program and load shader. I'm wondering where should we call for them. Let's see. The load shader functions takes the input of WebGL, etc. Add this code to your main. Okay, yeah. So this is where we call it to the main. Here's the main. Yeah, here we use the ones we added before. And then this one here. Okay. So we do that function we call init buffers, which will implement a separate JavaScript module as we explore more in advanced WebGL concept. This module we augmented to create a 3D object. Create a new file called initbuffers.js and give the following content. Okay, so we need to create a new file called this way. We add here the content that MDN give us. We export it as a function. Yeah. This routine is pretty simplistic. Give the basic nature of the scene for this example. So now we need to render the scene. Now create a new file called drawscene.js and give it the following content. Again, douche drawscene.js, and the content is copied and pasted. The first step is to clear a Canva, blah blah blah. Okay, now we need to import those files created in our WebGL demo. We need to do this at the top. Here they are. And then in our main function, we call. Let me hide the other functions, init shader and load shader. Here, after all of this, here we are. And the result should look like this according to the tutorial. So let's see. Oh, sorry, it's loading. Okay, we have what we wanted, right? Let's see, we have some warnings here. Yeah, getting the CSS. Yeah, we don't have the CSS. I don't get why they make us add it here because, well, they don't give us this file on the tutorial, or I can remember they do. Let's see it again. I can even try to CSS. Next. No, this is the only time in the entire page CSS appear. So I don't fully get it. Um, we can even hide this, well, command it to get rid of the warnings here, right? Yeah, now there's no warnings. But yeah, let's explore what we do because it was a lot. I know. Uh, let's do it file at a time. For example, here in the HTML, the only thing we do is we add this script, not only our local script, we add our remote script. Um, I am guessing this is some functionality WebGL already have, and they give it to us if we want to use it. Uh, Next, in our WebGL demos page, we import two files. We are going to talk about that, but the titles are well, really self-explained, right? This file, what this do is draw the scene, and this file, what it do, it's init the buffers. So again, we have our canvas element from the HTML. We get the rendering context from that. We checked if WebGL works on the browser we're using. We clear the colors and we get the colors, right? Then we add a value for the Vertex shader program. Here, I am not fully like understand what it is, but it is a constant value for what we want to do. In this case, is to uh, shade to render the vertex shader, right? Then the FS source. If you are not familiar with the FS, it's like, how to say it. Like in this space, we are going to use lights and this kind of things. So this is like a string containing a code from JavaScript. I know this is hard to get, but it's probably wrapping and passing a string to execute it before. Let's check on that because we're using it here. So probably in the init shader program, we can get more information on that. We initialize the shader. This will be all the light from the vertices and from its established. We collect all the information we need to the shader program, look up which attribute our shader program is using, vertex position, and look for uniform locations. So we pass the shader program, the resulting um, from the init shader function we call here as a program. Then the attributes we get from the context, the shader hypertext position, we get from the context the U projection matrix, the U model view matrix, and we store here in the program information. Then here's we can call the routine that build all the objects that we'll be drawing. We init the buffers. This comes from the file we import. We pass the context and we get the buffers. Then we use the buffers and the program information here we establish to pass it to draw the scene. Draw the scene is also a function coming from the draw scene model, right? In this shader program, we saw that we are passing the context, the BS source, and the if source. We saw the if source is a string function, and the BS source it's almost the same, uh, plus these things here. And what we do with them, it's the real question. Uh, we use a function called load shader. Okay. We get from the constant the shader source, the compile harder, passing the type, the source, and the context, right? And return the shader. What we do with that shader, we have the vertex shader and the fragment shader, and we pass that to another function of the context. Uh, and we link the program with that shader and return the shader program, which is the one we use here to pass to the programming info. Really complicated, right? Yeah. And we have even talked about what the drawsing do and the init buffer do. But we trust the people from the Mozilla web docs, and this works. That's the thing. And you remember, I want to say this to you like in person. So let me stop sharing. Yeah. As you see, this is not too easy, right? If you were thinking like, okay, yeah, I could do JavaScript because it is a lot of easy. It is easier than Java or C, and I don't have to worry about a lot of things. You see, it is not. We do three files. Well, for if you count the HTML, just to render a square. That does not escalate, right? That's why we use libraries as 3GS, as Play Canvas, as Babylon, as Phaser, as the one you want to mention, uh, just to not handle all the information required to build the animations. Um, that's the thing. If you want to, sorry, that was my charger. If you want to go deeper in how WebGL works, this is what it will be waiting for you. This is what you should expect. A lot of things on really complicated matters, um, but that's not to scare you. That's to encourage you to do it. To be honest, on my own, I don't like that much animation and video games to get into that. I prefer to use the libraries, the engines, and the tools I mentioned before to not handle that. Uh, Oh, your view screen is definitely frozen. Ah, sorry. I'll share with you it again. But yeah, that was just a clarification. JavaScript, it is a good thing to know. Building video games in JavaScript, it's easy once you get the full, well, not the full, let's say the right tools. And we will see it on next session on Friday. You will see that we can create really amazing things in just a couple of minutes. For example, we code this thing in like 20 minutes, and on our next section on Friday, we are going to use Play Canvas to not handle this amount of WebGL, uh, but to use all the power of WebGL to run 3D animations. This is not it with this session. We are getting started. Uh, let's add again my screen. Okay, you should see it now. And let's go to our next section using shaders to apply colors. Wow. Let's continue on this series of tutorials. Um, I think this just proves, well, it proves a lot of things, but one of the things I want to um, get it out of the air, uh, this it's not as easy, right? So we need to this function to init buffers module. Let me init buffers. Okay, we added. We add some color buffers from white, red, and green, also blue. At the end of the column clone, replacing the existing return, we should add this color buffer. Oh, it's from this, and we return the color buffer. Okay. Update the BS declaration in our main. Um, the key difference here is that for each vertex we pass it colors using a varying 2D fragments shader. So we go to our WebGL demo and we update here our vertex shader. Let's give it a nice separation. Let's continue with the coloring the fragments. We need to update also of fs source. For that, we copy and paste it. Come on, update fs source. Now we draw using the colors. Update the program info declaration in your main. Program info declaration. Oh my god, load shader, init shader. Oh, this is the one. Program info declaration. we updated it. Add the following to your browsing module. We go to our browsing module. We add it. I'm thinking at the end it's a great place to add it. And now we probably call and function from browsing before the WebGL prompt to call. Called set attributes function from browsing right before gl dot use program call. So gl dot call. No, it was not called. It was use program. Yeah, use program. So right before that, we need to add this set color attribute. And now our page should be updated to this. Oh no, init buffer, yes, 757. What is that? Oh, return not in function. Yeah, but here's the return. Oh, no. No, we are good, right? Um, we add this to our init buffers, const color buffer, return color buffer. Yeah. Then at the end of the inner buffer function. Oh, I get it. The export stays here. And the thing I should replace was this one, right? Replace the existing return. Yeah, yeah, I get it now. Sorry for that. And let's see. Yeah, we have our shaders. Oh, okay. Just for that. And for next, it's animating that. Make the square rotate. This was going to be the last thing we're going to do. And then remember, on our next session on Friday, we are applying this same WebGL with all the things you saw this far, but in a more easier way with just play canvas. Let's say it that way. Add this at the start of the code from WebGL at the start. So that will be here probably. Oh, this code. Okay. In your browsing model, update the declaration of browsing function so it can be past the rotation. Okay. Updated in your browsing function right after the mat for translate call at this. Let's look to mat. Let's look for mat for dot translate here. Right. Oh, right after. Right after mat for translate. Yeah. Yeah, we add this after this rotate matrix. At the end of our main function, replace the existing browsing call for this. It's now be called render main browsing. We need to replace this for this. Yeah, and let's see, it's working. So you see, this is very powerful. This has a really great performance, and you should think of using WebGL if you want to go that in graphics, not just in web. I remember WebGL, it's the web API for OpenGL, which is a graphics standard. But yeah, uh, think of learning more of this, and if you want to apply it to video games, specific for video games, join me next Friday to fully understand this. Um, well, not to fully understand. We we do a really complete session here. I would say to apply that knowledge to video games using Play Canvas and WebGL. Uh, so yeah, that was it. Let me read some comments and we can wrap up. Um, I am a beginner. Just want okay. Can't find the link to the WebGL tutorial by the end. Can you share it? Yeah, sure. Give me a second. WebGL. In the link I shared before, it is on the resources. No, sorry, in the guides and tutorials. But I can share the specific link for that. Don't worry. Just give me a second. It's loading. Oh, okay. This is low. But yeah, I got it now. It's almost the same with the slash tutorial. Funny, isn't it? Uh, so here it is. Here's the link to the tutorial we were following. Uh, okay. Jay, do you want to say MD? Okay. I think your screen is frozen. Oh, we resolved that. Hi. Yeah, I'm DM. Just black it and you are clearly visible. Oh, that's weird. Did you get anything of I was sharing with of the Visual Studio screen, or this happens all the time? like it happened all the time. I was sharing. If so, a thing I can do is upload the code I just write to a GitHub repository and share it with you. But so hard to follow along with screen. Oh, I'm so sorry for that. I didn't realize this. And I think that's really weird. Not much. Yeah, I will do that. I will upload this to a GitHub repository. Give me a second. I will do that immediately. So you can see all the things we done. I'm so embarrassed for that. I don't know what happened. And I wanted to share another link with you. This one's from Dev. This is called 10 best of games with with JavaScript. That's the thing. Uh, quickly to GitHub repository. Hmm. And again, again, apologize for that. I'm going to name it WebGL MDN tutorial. No description, no license. Well, yeah, license it. Repeat remote. Just give me a second. Yeah. Oof. Again, my mistake. Hmm. 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 Okay. This is taking more time than I was expecting. Sorry for that. Keep track on the on the Discord. I will post the link for the repository I will upload. Thanks for following. Thanks for the feedback. I really hoped you liked this session, and thanks for joining me. Remember, on Friday we are going to apply this to video game scenario in a real application, which will be using Play Canvas. And as you see, using WebGL vanilla just from the web, it's not easy, but it's really, really powerful. And the tools like Play Canvas or 3ds, if you don't want to focus specific for video games, uh, will help you a lot to quickly develop this, right? It was great. Thank you. Thanks, thanks. Well, happy hacking. See you. I made it. Here's the link. Uh, well, that's it. Thanks a lot again. And now, bye.